Hello friends, in this class we are going to learn about how to create LR0 collection, which is the fundamental collection on which LR parser is based on. Welcome again, and now we are ready for this creation of LR0 this LR0 collection. Okay, so now we are ready with this creation of LR0 collection, and here I have taken a grammar, a very simple grammar: S derive double A derive small a capital A, and A derive B. The first thing you will do here that you make the augmentation, and that is nothing but I'll add one more production into this. So S dash derive S derive AA, and then A derive small a capital A, and A derive B. So this is the augmentation. And then we'll start the closure operation, and then we have a series of go to statements. So closure operation begins with what? Putting a dot in front of starting symbol. Okay, so start symbol. So S dash derive dot S. Okay, and then dot is in front of S, so S derive double A, and then we have A derive small a capital A, putting a dot here, and A derive dot B. Dot is in front of terminals. We'll stop here, and this state I will call it as I0 state. Now, so once we are done with I0, now we'll do many go to here, and I'll tell you how much we have to perform this go to operation. So we will do one after another, and that operation is called go to operation. So we'll do here that on input S, what will happen? Okay, so that will become S dash derive S dot, and I'll call the state as I1. I will do here on input capital A go to I will do, and it will become S derive A dot A. But now the statement you remember from this go to, we have to calculate closure of it. So the I alpha x dot beta, and we have to perform closure of that. So now dot is in front of capital A, and we have to perform closure over here. So closure operation says what? That if terminal then end, if it is a non-terminal, then add the production rule small a capital A and put a dot A derive dot B. So now this is the number of states, and I'll call it as I2. Okay, now here on input small a, what it will become? A derive go to A dot A, and dot is in front of non-terminal, again closure of it. So A derive dot AA and A derive dot B. That is the operation, and I'll just put in one set, and I'll call it as I3. So what we are creating, collections we are creating over here. On input B, what it will become? A derive B dot, and that state I'm calling it as I4. So now are we done? No, we are not done. What is the idea? That in this collection we have to make sure that all the dots reaches till the end. So now here it is at the end. Now this will move further. Okay, so this will move further, and I'll on input capital A, this will become S derive A dot, and no more symbols. So now this will be done. So this is your I4 state. This is interesting. What will happen on input A? So here on input A, this is A derive A dot A, and A derive closure of it small a capital A, and A derive dot B. But if you look at this collection, this LR0 collection, and if you look at this I3 state, both are same. Okay, A dot A and dot B. Remember, same means dot same number of item. Okay, this is same number of items, and dot in same position. Okay, then otherwise it is not same. So everything, it should be a mirror or exact replica. So now this item already I have over here. So for that, what I will do here, that this on input A will go here, on input small a it will go over here. A derive B dot, so A derive B dot is already there, so on input B this will move to this A derive B dot small b. Now further this we are done with this part. Down A dot A, so now on input small a, what will happen? On input capital A, sorry, so this will become A derive A dot, and this is what your okay, I4 I have already, this is I5, and this will become your I6 state. Okay, on input small a dot a, so same thing will happen over here, that it will become your so A derive here A derives, what should I write here, a small a capital A dot, okay, A derive here A dot A, and then dot is in front of A, so dot AA, and A derive dot B. Now this collection, again it is the same situation like this over here, and for that same A dot A dot AA, okay, there is a dot, okay, A dot A and dot B, okay, so that is same, and for that reason what will happen over here, that this will make a loop on input small a. Okay, and here we are done, almost done, and here on input B it will go to the A derive B dot. Okay, so this I0 to I6, okay, this I0, I1 and up to what, I6, this is called canonical LR0 collections. Okay, so that is the canonical LR0 collection. Now we'll use this and now we'll create table based on this canonical LR0 collection. We can create two tables. So one is your one table is your LR0 parsing table, okay, and another one is your SLR, and sometimes referred as SLR1 parsing table. So both we can do by using this collection. You have to practice enough to create this collection, okay, and this is the least requirement to understand the bottom up parsing. Okay, so we have to shift the dot, we have to do the closure operation, and then go to the new state till when we have to do, till I achieve these states. These are very important. S derive S dot at the end, A derive A dot at the end, A derive small a capital A dot at the end, A derive B dot at the end. These are situation that we want to achieve, and these are your what item? These are your reduce item. Okay, this where dot is at the end, reduce item, and this is also a reduce item, and this is also a reduce item, and of course this is also a reduce item. Okay, so that's all for this discussion. Thank you.